Now, if we talk about novel view synthesis, okay, so now we saw that, okay, what is novel view synthesis, what exactly it is, the technique that we got to know. We also looked into the challenges, the problem of novel view synthesis. We looked into the application of novel view synthesis. Now, the very big question, how exactly we can achieve, how exactly we can do novel view synthesis? What are the ways for that? So there are two ways, like we can do it via traditional photogrammetry, like it's the traditional approach. So this is also like the structure from motion. So the idea of this traditional method is structure from motion. So the classical approach matches feature points across images to triangulate a 3D mesh. So what it means, I'll tell you. So now we are learning how we can do novel view synthesis. So now idea is very clear that I will be provided with image along with the camera pose, that okay, this image was took from this angle, this image was took from this angle, this image was took from this angle. So this information I will be having. Now from this information, how I will be able to do synthesize novel images using the traditional approach. So in traditional approach, what we used to do is, first we used to do the feature detection. So whatever sample we have, images and the pose angle, we used to detect the feature. And in feature detection, we used to focus on like the corners, edges, and then we used to do the feature matching. What we do, like whatever input we have from every image, we used to detect the features. Then we try to connect the dots, that we call it feature matching. So now we try to match the feature, that okay, for this image the border is here, for this image the border is here, and this is the pose angle. So a sort of, we are trying to recreate the scene from the information of in the image and from the pose angle. Then we used to do structure from motion. So after feature matching, then what we used to do is that with whatever insights we have derived, we used to identify the structure from motion. So now we will take different camera poses together, and we'll try to recreate a structure based on the features. Like I'll join this border, this edge, this edge, this edge. Oh, this is a triangle I'll get, like that. Like a very basic idea I'm giving. So see, this is not like we will go very deep. It is like to get an idea. And if you're interested, you can dig very deep, because it's very interesting. Like novel view synthesis is very interesting. You can go very deep and you can actually do it. Then we have multi-view stereo. Okay, then after structure from motion, we will have something called as multi-view stereo. Then with that multi-view stereo, we will have mesh reconstruction. We'll reconstruct the mesh, and on top of the mesh, we will add the texture. So here, what has happened, I'll tell you, like the main thing we should focus here is, see, whatever input we had from every image, we did the feature detection, then we did the feature mapping. Now that feature mapping and then the structure from motion. So whatever structure we got, it is highly discrete in nature, because it does not contain, it is not continuous, it is discrete. So many missing information is there. And then from multi-view stereo, still it is discrete, as you can see, many missing gaps is there. Then we will just connect the points. So to fill the gap, we are connecting the points with the straight line. So we will get a mesh. From discrete structure, we were able to generate a continuous surface via mesh. So all these discrete points, we just connected it with lines. We got a mesh. Then on top of that, we applied the texture. And here, lightning plays a very important role, because whatever information we have from the input, that we will make use of to apply the texture. And in this way, all the unknowns we were able to build, because we had discrete information, but with the mesh, like I connected it with straight line, I was able to generate a continuous surface, and that too in 3D. So I was able to generate a continuous 3D realistic experience from 2D. And the beauty of this technique is that it also contains realistic experiences in unknown poses, the angles from where we haven't captured the images. That angle also it covers. We can see that, okay, from this angle how this object will look. So the advantages of the classical method is it is physically interpretable geometry, and the pipeline is very deterministic in nature, because like we are doing a fixed set of tasks. So once you make this pipeline, very easily you can do it. So fixed set of tasks we are doing. So it's like a deterministic pipeline we are following. Now the limitations with it is, so we need some good amount of images. So the more the images we will have in input, more realistic the output will be. Okay, so the challenges, we already saw that it struggles with reflective or textureless surfaces, and poor performance with sparse input. Because if the input sparse input means if it is spread, if the input is spread, then the performance will be poor. So that is the traditional or the classical approach of novel view synthesis.